review of the organic chem unit, which would be helpful before a unit test or before you write a final like the diploma. So when you start organic chem, the first thing you learn is what an organic compound is, and you know that it will be compounds containing carbon. Then you start to see what is the exception, what would make something inorganic. And that would be things like that include the carbonate ion, the cyanide ion, carbides. If you had any oxides, like anything bounded to a metal, all of these will be inorganic. Oh, that's a weird line. So the first type of question you might see, and these are old diploma questions, is being able to look at a list and identifying what is organic or possibly what's inorganic. So this list is asking for organic, so things like number 1, and it's a carbide. Sorry, it's a little bit lagging here. So not number 2. Number 3 works. Number 4 works. Number 5 does not because it's a carbon dioxide. Number 6 does not because of the CN ion. Number 7 works, and number 8 does not because of the metal and the ion CO3 with the -2. And then just having a look about how these questions can be a bit repetitive. This next one, same idea, seeing what's organic. And these questions, just read it carefully because, again, I could have asked what's inorganic. But in this one, what's organic would be compound number 1, not 2 because of the metal and the carbide. Number 3 works, number 4 works, not 5 because it's an oxide. Number 6 works. 7 and 8 don't work for 2 reasons. 1, there's metals, and attached to. Then you start to move on to taking a look at being able to describe organic compounds in daily life, like knowing that alkanes are often used for fuel. We'll also know how to separate crude oil, and we'll look at that in a moment. You also will take a look at these 2 reactions that you should have memorized, hopefully from when you did thermo, so like photosynthesis and cellular respiration, so being able to write those reactions out. So here's one that shows that we know photosynthesis and carbon combustion, hydrocarbon combustion. So the first part, the reactants in photosynthesis. So if you don't know the photosynthesis reaction, you might find this one a little bit challenging. So we know that photosynthesis, you will be taking in carbon dioxide and water, and you produce oxygen and glucose. And so when I'm looking at my reactants, I'm taking in carbon dioxide, so number 3, and water, so number 4. And then the next part, the products of hydrocarbon combustion. So combustion, you have a hydrocarbon in the presence of oxygen, and you produce carbon dioxide and water. Now, the reason why we have a choice between a liquid and a gas is because of this word open system. But in an open system, your gas or water can escape as a gas. So this is number 5. If it asks you in a closed system, like maybe calorimetry, you would pick number 4 because if water cannot escape, it will just be liquid. Then a huge portion of organic in grade 12 is just naming and drawing. So we want to be able to name alkanes, knowing that that's single bonds, knowing that they're saturated, and that they end in A and E. You want to know how to look at alkenes, so knowing those are double bonds, alkynes, triple bonds. And as soon as you have a double or triple bond, you are unsaturated. You want to know how to name cyclic, benzene, and benzene is always aromatic. And if you have benzene on a branch, it's called phenyl. You want to know how to name your branches, and you want to tell if it's polar or nonpolar. Another part that we're looking at is functional groups. Functional groups are always going to be polar. Oops, that just moved, and I didn't mean it for it to. And so things like having halogenated hydrocarbons, so putting on a halogen, how to name it, alcohols, carboxylic acids, and esters. We're just going to take a look at some of those. So looking at this first one, we have something that is cyclic. So we have a methyl group and an ethyl group. When you're naming, it wouldn't matter if this was 1 or 2. What does matter is that you're naming ethyl first because that's alphabetical. E comes before M. So this would be ethyl and, 1 ethyl, 2 methyl, and then you need to see the word cyclo, so cyclobutane, butane being 4. This next one here, looking at some line diagrams. There is such a lag on my laptop today. This one's asking the name of compound 3. So compound 3, we want to find our longest chain. So we'll have 1, 2, 3, 4, 5 methyl groups to right, so that our smallest side group is on the lowest number possible, which is number 2. So this is going to be 2, 3, dimethyl, and then pentane. So if you numbered your carbons from right to left, you would have gotten this one wrong. You also want to be able to identify isomers. So this one is asking which compound could be C8. So when I use these questions, I usually start with the C8, making sure you see 8 carbons. So the first one's possible. The second one's possible. 2, 3, 4, 5, 6, 7. Wait, how much did I just count? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, so all of them are possible. So now I'm going to look. Find that helpful to just draw in. So not that this drawing's that great, but that means this carbon right here has 1 hydrogen. This one has 1, this one has 1, this one has 1, and this top one has none. So this would be 3, 4, 5, 6, 7, 8, 9, 10. So that one would work, and this would be ethylbenzene. If we look at the next one, we have 1 carbon here, or hydrogen, 2 here, 2 here, 2 here, 2 here, 2 here. So counting them, we have 3, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have too many. Oh no, sorry, I thought that was a 10. It's 16. So it's not that one. It could be this one. So this is an ethyl group. 1, 2, 3, 4, 5, 6. Okay, now I'm thinking it looks like it's B, because it is definitely C8H16. It's cyclohexane, all single bonds. So let's look at the next couple. So we already know that, okay, it's not going to be this C because that's not named correctly. Cyclo has to go before pentane, and that's not propane. And then this last one could work because it is named correctly, but let's see if we have the right number. So we'd have 2 hydrogens, 2 hydrogens, 2 here, 1 here. They'll fill in a second. My thing is just lagging. So that's 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that is propyl group. Oh, and the reason why this one's wrong is it ends in ENE, meaning there should have been a double bond. So the answer there is B. This next one, the molecular formula for 2,5-dimethyl cyclohex 1-ol. With this one, I would suggest to just draw it out and then count. So if I draw hexane and I put an OH group here, and then that would be on carbon 1. If I name it this way, 2, 3, 4, 5, 6. So right now my numbers are showing the number of my numbered carbon. So on carbon 2, I need a methyl group. And on carbon 5, I need a methyl group. Now, on carbon 1, I would have 1 more hydrogen, so 1 more. On carbon 2, I'd have 1 more hydrogen. On carbon 3, I'd have 2. On carbon 4, I'd have 2. On carbon 5, I'd have 1. And on carbon 6, I'd have 2. So now let's count all our hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this looks like our answer would be D. And some people could see this. I can't see it without drawing it out, so I just draw it out quickly. I like these ones just showing the naming. So looking at the number above, name an alkene. An alkene must end in ENE, so that would be number 1. Naming an alcohol ends in OL, that would be number 6. Contains a triple bond, we need a YNE, that would be number 4. And then something that is cyclic and saturated. If it's cyclic, you want to see cyclo. If it's saturated, it has to have all single bonds, so ANE, and the only option here is number 5. This next one, benzoic acid, contains, so if it's benzoic, you would have a carboxyl group. And if it's benzoic, that means it's coming from benzene. And if you have benzene, you're aromatic. So that one is going to be A. So we'll rule out these two and then say aromatic because of the benzene ring. The next one, 2 properties that cyclopentanol and pentanoic acid have in common are they have the same number of blank, and they both are blank. So cyclopentanol, so pentane would be the parent chain, and pentanoic, pentane, number 5 again, would be in the parent chain. So I'd probably take this one away. And then because we don't have a benzene ring, they're not aromatic. So it looks like our best answer here is C. Sorry. This next one, both 2-methylpropane and 2-chloromethylpropane contain, which one would this be? 2-methyl, 2-chloral, 2-methyl. They would both have a functional group, the methyl. No, that's not a functional. That would be a branch. They both have branches on carbon 2. And if it's propane, they have 3 carbons in the parent chain. So because the first one doesn't have a halogen, it does not have a functional group, but it does have a branch. So if you have methyl, ethyl, propyl, those are branches. Okay, we'll keep going here. So we've talked about this already, saturated versus unsaturated. So saturated means every carbon is bonded to as much atoms as possible. So this would be considered a saturated hydrocarbon because it can bond to 4 other atoms. Where as soon as you add in a double bond or a triple bond, now you have less atoms you can bond to. So this carbon could only bond to 3 other, so it's not saturated. So just looking out for that. Double bond to an oxygen is considered saturated. So if you have carbon double bonded to one oxygen, and then you are bonded to others, we're not going to say this is unsaturated. That's still going to be saturated. Looking here, hexane and hex-1-ene are both colorless liquid. This one is saying that we're going to add in a few drops to differentiate, and we're putting it into bromine. But even though it refers to the bromine test, this is just showing saturated versus unsaturated. So hexane, right, A-N-E would be saturated. Hexene would be unsaturated because of the double bond. So this has to be B. This next one, doing the exact same thing. Again, I hope you can see how these questions get very repetitive. A-N-E, saturated. E-N-E, unsaturated. Aliphatic versus aromatic. So if you have a benzene ring, you are aromatic. If you don't see benzene, you're just aliphatic. So this one here, looking at our compound, we would be able to see there is benzene, so it has to be aromatic. And then recognizing that you have a functional group, and that is carbon double bonded to an oxygen, single bonded to OH, and that's a carboxylic acid. The next one, cyclohexene and benzene have a different number of, that would be double bonds, right? This only has 1 double bond within, and this has 3 double bonds within. So not carbon atoms, but both of these are cyclic, right? Cyclo and benzene is in a circle, so this would be C. You can also rule out alkanes because to be an alkane, it has to end in A-N-E. Now we're starting to look at a little bit more. It looks like we're looking at a reaction, but then it's not asking that. So in this one, it's asking, if you look at the above equation, molecule 1, which is here, is going to be aliphatic because there's not a benzene ring. And molecule 2, which is here, is considered to be A. And then this one, well, let's see what we have. So your choices are alcohol or ester. So you don't have an OH group. Well, you do, but it's bonded to the carbon, and that would be a carboxylic acid. But this link in here, that's showing an ester link. So your answer is A. Okay, so about halfway through the review, and if we keep going, what you also want to be able to do, identify your halogenated hydrocarbons, your alcohols, how to name them, carboxylic acid, looking for that COOH, and then esters, how to name them and how they're formed. So just looking over about how to identify. So an ester, you're looking for that carbon double bonded to an oxygen, and then you have a chain, and then it's single bonded to an oxygen, but instead of having a hydrogen like you would to be a carboxylic acid, you're bonded to another carbon, and that could be bonded to other things. So looking at our ester group, we definitely have one here. So carbon 3, or compound 3. We also have one here. So I'm looking at 3 and at 2. And that is all I am seeing. So I believe the answer here is A. Another one just showing again how these can be a little bit repetitive, but I like questions like this because as long as you know what you're looking for, you're good. To be aromatic, you have to pick 1 or 2. To be a carboxylic acid, you're looking for that COOH. To be unsaturated and alphalic, you are looking for a double bond and no benzene ring, which is number 4. And halogenated hydrocarbon, the only choice we have here is number 2. So don't be afraid that you might have more than one option. That when you do get graded, it would accept, like for question number 1, you could have had 1, 3, 4, 2, or you could have had 2, 3, 4, 2, because 2 would have worked for being aromatic as well. Okay. Again, looking at what we have, question number 9, we have looking for an alkene. I just like to look straight at the ending. ENE makes it an alkene. An alcohol and an OL. Triple bond has to end in YNE. And cyclic and saturated. Cyclic, you're looking for cyclo. Saturated, you're looking for ANE. So number 5. Okay. Keep going, being able to identify. So your alcohol, looking for that OH group. Number 4. Aromatic, looking for that benzene ring. Carboxylic acid, looking for that COOH. Halogenated hydrocarbon, you're looking for a halogen. Okay. Over here, you're looking at butanoic acid, can be described as, and the functional group is. So butanoic acid, you don't see any benzene, right? Butane is 4 carbons, and ending in COOH, you're a carboxylic acid. Oh, sorry. It's not aromatic because you don't see benzene. I meant to cross that out. And COOH. Okay. We keep going. The structures that describe methyl cyclopentane are. So methyl cyclo, it's not number 1 because that's a benzene ring. It's not number 3 because this is an ethyl group and this has 6 carbons. So it has to be number 2. To describe it, because of that methyl group, you are branched. Because you have only single bonds, you are saturated, and it ends in ANE, meaning you're an alkane. Now, isomers, I find the questions for isomers can take long, but the concept is easy. The concept is if you write out the chemical formula, so the condensed formula, it has exact same number of carbons as it does hydrogens. So if we start looking at this first one here, so it's asking which ones are isomers of the first. You have to figure out what you have in the first one. So for example, so I just don't want this pen here to die. It's saying it's low, so that's not fun. We'll count. So we have 4 in the ring, and then 5 from the methyl group, then 6, 7, 8 from the ethyl group. So we're looking for C8. So I would start with that first, all the ones with 8. And then you're looking for the same number of hydrogens. So counting your hydrogens, you have 3, 4, 5, 6, 7 from the ethyl group, 9, 10, 11, 7, 10 adding in the ethyl. You have 1 here, 2 here, 2 here. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you're looking for a C8H16. So at this point, you are just counting. So I'll skip this one, just going through it. And just counting your carbons, counting your hydrogens. If you have something like question or compound 6 and you can't tell, draw it out. Like for me, I'd probably have to draw these out and actually count them, but just taking a look at that. This next one being a structural isomer, that's still the same thing. You have the same amount of carbons as you do hydrogens in each of these. They are just arranged differently. So for instance, if I want a structural isomer, I would have in compound 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6 carbons. It's comparing it to number 5. 1, 2, 3, 4, 5, 6. So possibly it has a double bond, possibly, but then you have to count hydrogens. So it looks like that's a possibility. So I'm just, again, my pen's going to die, so I just want to skip a few of these questions going out, but just looking through it, looking for the exact same amount of carbons as you do hydrogens. Again, if it's structural, it's just arranged a little bit differently. Okay. This is same thing. If it's C5H10, for myself, I would draw out numbers 1 through 7, unless you know the formulas, which I never memorize. I just draw it out and then count your carbons, count your hydrogens. You want all of them to be C5H10. Okay. Now this is going into a little bit of the theory behind this. So you want to know the physical properties. So like boiling point, the longer your chain is, right? So like pentane is longer than methane. The longer you are, the higher your boiling point. Polarity, so if you have something that is polar, you will have a higher boiling point. Solubility, just don't forget what you already know, like dissolves like. So polar molecules will dissolve in water or anything that's polar, non-polar will not. And then the longer the chain, the less polar it becomes. So looking at question 19, starting to take in some of that information, you are using the information from the table. So we say we have butane 1-ol. You see that it has a high boiling point. Butane 2-ol, so just moving where that OH group is, the boiling point is a little bit lower. And then you add in a methyl group. So you still have 4 carbons, but they're just arranged differently. And now your boiling point's even lower. So using only information from the table, when the alcohols in the table are compared, they have the same. So they would have the same molecular formula because each of these would have 4 carbons and the same amount of hydrogens, but they differ in your physical properties like boiling point. So that would be B. Okay, looking at some of these molecules here, butanoic acid, methanoic, octanoic, and oca-deca, so a very big carboxylic acid. List from lowest boiling point to the highest. So the lowest boiling point would be the smallest molecule, so number 2. Let's see if my pen is a bit more charged now. Oh, that's good. So your lowest would be the smallest, so number 2, and then number 1, and then as you get bigger, the boiling point gets larger. So then number 3, and then number 4. Looking at the next one, the production of propane-2-ol, so what we see as a product from propene is A. So this is now going into organic reactions. If you're breaking a double bond, like we would be doing here, that is an addition reaction. And then propane-2-ol is likely to be, because of that OH group, you should be soluble in water. Okay, so next part is looking at those reactions. So we just looked at addition. Elimination means you are taking something off of your molecule, so you'll end up with a double bond and a small molecule. Esterification, combining a carboxylic acid with an alcohol to make that ester and water. Because you're producing water, this is also known as a condensation reaction. And then substitution is when you have a molecule plus a small molecule, and they are something on that bigger molecule will swap with the smaller molecule, and you'll still have 2 molecules on each side, meaning 2 reactants, 2 products. So going through this, during an organic reaction, an unsaturated, meaning a double or triple bond, becomes saturated. This is an example. So if you were unsaturated and becoming saturated, that means the double bond is broken, and that's an addition reaction. When pentene and hydrogen gas undergo an addition reaction, the resulting product is a halogenated hydrocarbon. That's true. Contains a double bond. That's not true because it will break. An alkane, that, oh, sorry, this is wrong. It's not halogenated. We don't see a halogen. An alkane, yes. Pentyne, no, we're not producing a triple bond. Okay. Looking here, if aqueous bromine is added to the samples that would cause the bromine solution to lose its color. So now this is referring to the bromine test. If you add bromine to a double bond or a triple bond, it will be absorbed by the molecule. So we're looking for anything with an addition reaction. So number 1 would work, number 2 wouldn't, number 3 wouldn't, number 4 would, number 5, and number 6. So what is that? 1, 4, 5, 6, that is A. Just a little bit more here. Now looking at esters, esters have a pleasant aroma. Hopefully you did an esters lab where you can produce some. And this one, to produce this reaction, so whatever's attached to the single oxygen, so the single bonded oxygen, that is coming from the alcohol. So this alcohol has 2 carbons, that's ethanol, and whatever carbon is attached to the double bond of oxygen, that is coming from the carboxylic acid. So that is 1, 2, 3, 4, 5 carbons. So you would use pentanoic acid and ethanol to make that compound. Here we have a reaction, and it's asking what we have to do to make 1,2-dibromo. So to do this, you would be breaking a double bond, so it would be an addition reaction, and the product of the reaction is 1,2-dibromo, then 2 of them would be ethane. So once the double bond is broken, right, you don't have any more. Let's just double check that. So if you had carbon, carbon, double bond here, hydrogens, yes, so this breaks, this one breaks, each of these can get one more, and then you'd have ethane. Naming the reaction, type of reaction, you have a carboxylic acid with an alcohol. This is an esterification reaction. Compound 1, going back up for a second, compound 1 is looking at this one here. That is a carboxylic acid, ethanoic acid, that's number 2. Compound 2 is actually the ester. So this part comes from the alcohol, and this part comes from the carboxylic acid. So the alcohol is named first. So this would be ethyl ethanoate, that is number 3. And then the last one, classification of compound 2, that is your ester. Okay, just a little bit more here. So just, again, looking at some more reactions. Maybe I'll skip a few because I think it might be, I don't want you to lose the attention, and we still have to look at polymers. So lastly, the last part of this unit is polymers. So knowing that if you link molecules together, you have many of them, and you will get a polymer. So the analogy here is taking a look at a paperclip. That would be your monomer. If you link a bunch of paper clips together, that would make a polymer. So there's 2 types of ways to form it. You can form it by breaking the double bond and then linking the polymers together, or condensation, where water comes off and the rest links together. So looking at this one, because you have double bonds, that would be, well, this first one is not actually about it. This one is showing like it's going to be a polymerization, but then it's asking just about ethene, and ethene is going to be unsaturated. Then now we take a look. Ethene would be the monomer, because that is the link that's being repeated, and it's converted to polyethylene by a addition reaction. So monomer, it's not esterification, so we'll say polymerization. I think it's more common to see addition there, but that's okay. We can rule out esterification. Which of the following rules identify a reactant and its product in a polymerization reaction? So you start with your reactant, and then you just add poly to it. So it's not A, polyethylene. It could be B. It's not C, and it's not D, because this should say propene instead. So that one is B. And then lastly, technologies related to organic. So the main one is fractional distillation. You might see a few more like crackling or something like that, but it's not, usually they'll give you more information. And literally all you have to know is when it comes out of the ground, you can separate crude oil by fractional distillation, and they are always separated by boiling point. So whatever will boil first will come out the top, and then the heavier compounds come out the bottom. So like what we're seeing here. So crude oil goes in, and to separate crude oil, you boil it. The first ones to boil will come out. So the light ones will be up here. The heavier ones will be down here. And that is our very, very fast review of organic. I hope you found it helpful. If you did, please subscribe. If you have a test coming up, good luck. And if there's any other video I can ever do for you, just let me know in the comments. Thank you for watching.